Okay, so last class, for the coding part, we discussed function, Q function. So starting from this class, we start with indexing and slicing. And if you recall, indexing is to retrieve single item. And the slicing is a subsequence. Okay, and if you recall for indexing, we plug in the position, the index. So it can be positive, can also be negative, and starting from 0. And if it is negative value, so it's a count from back. And for slicing, the syntax is you have start, end, and step. So you get the sequence. Here, this is exclusive. So for the ending, it's exclusive. So that's a general concept, okay? So next, let's take a look at the example. So this var list, so this is a list. We have 1, 2, 3, 4, 5, 6. We have 6 elements. So to access the first item, so you do sub-0. Okay, so this is the starting. So this 0, 1, 2, 3, 4, 5, 6. Okay, so this is sub-0. So you get the first item. To access the last item, you do -1. So if it's negative, count from the end. So it will be the last one. So this dictionary, okay. And the other way to get to the last one is you can also do var list, and you find the length of this list. So the function to return the number of elements is called length, okay? But then you need to -1, okay? So this will give you the last one also. And over here, so here we do slicing. So starting from from the second one, so second one, third one, the fourth one. This is not included. So it will get these 3 items. Okay. It didn't do the step. So the default is 1. So it's every 1. Okay. And we can also use slice assignment to append a list at back or at front. Okay, and also can remove part of the list. Yeah, so that's quite useful. And here it shows, so you can do the var list to use the slicing. So the starting will be so in this case, this is 0, 1, 2, 3, 4, 5. Oh, not 6. So this is 5. Is it? And so the length is 6. So it will start at 6. 6 right now hasn't there isn't anything, is it? So starting from there and depends. Okay, so all the way to the end. And then you assign the list, a new list to this. So this will serve as you append a list at the back. Okay, you append it at the end of this existing list. And previous class we learned you can do if you want to add a single item, you can call append. If you want to add multiple, you can call extend. You can also add some other list is using the plus, so concatenation. And here, using slicing, you can also do this. And how do we add at the front? Then you didn't specify the starting index, so that will go with default, but the ending will be the first. So then you're going to add this one to the front, okay? We can also use slicing. Okay, so this is started from the 10th all the way to the end with empty, okay? So what this serves is remove. So this slicing, then you assign it to empty list, so it will remove that part of the list. So the subsequence will be removed, okay? And we can also use negative step to do reversing. So to do that, to completely reverse this list, then so what here we do is colon, and then -1. Is it? So no, didn't specify start, didn't specify end. So by default, it starts at the beginning all the way to the end. And the step is negative. So that means you start from the last to the beginning. Okay, so that's why you can do reversing. Okay, so this is regarding indexing and slicing. For list. Let's see. Next, what we are going first to discuss is about the zip function. Okay, also quite useful concept. Zip. So what zip function, last class, the concept we already learned. So it's to pair multiple sequence together. Okay, so let's see. So we have this list. So this is a list has 2 string, and this is second list regarding price. So each of the list has 2 items. Then you do the zip. You pair these 2 lists. So what it's going to do is we'll pair these 2 together and pair these 2 together. Okay. So what it will return is Google ticker and its price. And pair the other one, it's Tesla, and its price. Okay, and zip will return iterator. So it's not a list, not a tuple, okay, not a set. So it returns an iterator. For the iterator, so it's also something in sequence, okay? But if you want to directly output iterator, it will not output all of the items in the iterator. It will only give you the location, output the location. And if you do want to output every one item in the iterator, you can use the for loop, okay? So in other case, you can do like for variable in zip. What you can do is that pickers and prices. Then you do like a print. Wow, you can do something like this, okay? So you need to use a loop to individually, one by one, to output it. So That's the concept for iterator. And if you just want to output the whole thing together, that's why here you use the list. Okay, so we call list constructor, and you pass in. So here you plug in an iterator. Plugging an iterator to the list constructor. Then it will, so this stocks is a list, so it will output a list of tuples. Okay. And last class, I remember we also explained iterator. Okay. So iterator versus list or tuples or other data structure is iterator each time to only load one item. Okay, so it load the item by demand to memory. So that's why I say it's memory efficient. While for list it load all of the elements into memory. Okay, so that's the advantage of iterator. So for iterator, you can even do infinite sequence, okay, because it's load one by one. So that's zip function, quite a useful function in Python when you wanted to pair and aggregate. Okay, so it pair items from multiple sequence together and then aggregate them. Okay, and the next concept, the next coding examples is regarding single asterisk used in parameter, in function parameter, or argument, as well as the double asterisk. Okay, we're going to take a look at the example. Okay, so first we define this do unpack function. So this function has two parameters. Pretty simple one, just output the ticker and the price. Okay, and then over here we use a loop called the stocks. So the stocks is the list. So it has two tuple, okay, two tuples. So the first time what it has Google, and the first time it has Google and 172. That's this stock. Okay, so it's a tuple. And then you call the do unpack. But do unpack, suppose what it's supposed to have is two parameters. So you're supposed to pass in two arguments. But we pass in what? The stock itself, this is a tuple. One tuple, is it? So it won't work if you don't have that asterisk. If you just call do unpack stock, it won't work. Okay, that's wrong. Because the argument doesn't match the parameter, is it? Yeah, so in order to solve the problem, we can add the asterisk. If you add this asterisk, then it will unpack Google and 170, unpack the tuple. So what it will have the Google So this will match the ticker and 172. It will match the price. Okay, so that's the unpacking, how the unpacking works. Okay, the next one, let's see. Here we have this function called sum all. And the parameter just looks like just a single parameter, is it? But it has a asterisk ahead of it. So what this means, so this means it can catch variable number of arguments. So you can pass in sum all with one argument or with two argument, with three argument, four argument, five argument. So it's variable number. So very flexible then in this case. Okay. So what this function does is just whatever number of variables, it will add them together, do the accumulation. Okay. So then you see in this case, we call sum all and we pass in with five arguments. And with this asterisk, it will catch all five of them. Okay, so this is very convenient because in some cases that may dynamic change the functions arguments. In that case, then you can define using the single asterisk for the parameter. Okay, then let's take a look at the next one. The next one, we can first take a look at the function definition. So this time it's called unpack dictionary. So if you take a look, okay, it has, looks like just a single parameter, is it? But before the parameter, it has two asterisk. Two asterisk. Okay, and so this is called keyword argument. Okay. So keyword is you have the variable and you can also provide some value with it. So for variable, okay, equals hello. Something like this, okay. And in this case, let's see. So here it says, okay, it has key and the value, okay, in this keyword. So in this case, it's a dictionary, okay. So want to get off the item, so it gets the key and gets the value, okay. So then you output. So that's what this function does. And if you recall, previously we have that ticker and the price, is it, and we call list. So it will return list. If you plug into the dictionary, that will create a dictionary. Okay, so the dictionary will be Google and 172. And another one is Tesla 175. Okay, so this is a dictionary, stock dictionary, is it? So then you pass in this stock dictionary. You pass in also with two asterisk with this dictionary, okay? And then because the dictionary to get the items, so it will be first to take of this, it find the key and the value, okay? That's how this works. Two asterisk for both parameter and arguments. Okay, the next part, what we try to show is also quite a useful concept, okay? The comprehension, if you recall. And we can do list comprehension, tuple, or not tuple, list, set, and dictionary comprehension, okay? And another concept is a generator. And generate basic iterator. So it's a special type of iterator, okay? And tuple doesn't have comprehension, but you can borrow like a generator to generate something kind of like a tuple comprehension, okay? But we don't have that specific tuple comprehension. So let's see, before we learn how to code the list comprehension, let's take a look at this case. So we have this list, has quite a number of items, is it? And here we create an empty set, okay? And what we try to do is we try to find all of the strings of the strings in this list. Okay, so what we are going to do is using the for loop and check if it is string. Okay, if it is string, then you add that item to the set. Okay, so you create a set. Create a set using an existing list. Okay, that's what we do here. Okay, and if you output using, and even though you have multiple like hello, it will only add one hello. Okay, because for a set only take unique items. Okay, so that's what the normal way so far we learned. But let's see, for all this list, set comprehension, dictionary generator, both basically you can create a sequence with an existing sequence with only one statement. One statement. So one line of code. One line. Versus here, how many lines? We have 1, 2, 3, 4. We have 4 lines. Okay, so let's see, how do we do that? So here is that list. Is it to build a list comprehension? We want to get off the string into a new list. So that's how the comprehension works. So expression, for, and condition. So we first take a look at this for part. So this is going to loop through, so kind of like this for loop statement, is it? And then you next is the condition. So if the variable is string, is it? Okay, if the variable is string. So we don't need this add anymore. So it will go to here, expression, okay? So expression, loop, and condition, 3 part. And then you put them in a list. So then you can create a new list, okay? So similar for the set, let's just use the curly brackets, is it? So expression, the for loop, and the condition. So we know how to do list comprehension, set comprehension. Next, let's take a look at dictionary comprehension. Okay. So here we have two lists. One list, second list, symbol and price. Okay. So to create the dictionary comprehension, what we do is we loop. We do the loop. Okay. And here we call the zip. We use zip to pair two lists. Okay, call zip to pair them and then aggregate them. So it's going to be an iterator. Because it's an iterator, so that's why you can use the for loop, is it? And because here you pair them, so there are two items that you can carry. So symbol and price. And then you just put the expression. Expression is a dictionary, is it? Dictionary item. So you use a colon to create this expression. So then this will be a dictionary. Okay. Well, next is build a generator comprehension. So generator just use the parentheses. Okay, so similar. For loop, the condition, and the variable. Basically, it's a loop variable. Okay, so then it's a generator. And if we do print out, we will see that it just gives you the location, is it? And if you do want to output of them, so then you need to use the loop. Okay, for loop, then it will output. And with this generator comprehension, then you can call tuple. So tuple comprehension, if you just write one line of code to generate a tuple from existing sequence, you can borrow generator comprehension. Then you just call the constructor, plug in that generator comprehension. And then let's see what the generator itself, if you output what it is, so that you have some idea. Okay. Yeah, if you take a look, is it? So that's what, if you want to output, do the print, the generator, that's what it will return. So some location, is it? A memory location, that's what it takes. But if you do the for loop here, then it will output one by one. Okay. Okay, the last part of the code from this chapter is regarding lambda expression. And last class, we already learned, is it lambda expression, basically it's anonymous simple function. And it's also inline, okay? Because it's inline, so it doesn't have function call overhead. Overhead, okay. Why? Because function basically, it has in memory, it has a runtime stack. Okay, so function, okay. So each function, is it like function one, function two, something like that, is it? So it involves put the function to the runtime stack. And when you call it, you need to pop it, that push and pop, get the function out, and then for execution. So this will involve the overhead, is it? Then for inline, so for lambda function, lambda expression, it will not in the runtime stack. So it's directly in line with the code. Okay. So that's why inline function, it's more efficient, okay, considering when running. But if the function body is complicated, okay, it's not a simple. because normally for lambda is simple. If it involves a number of line of code, it's not simple, then not recommend to do lambda expression. Okay. And also because it doesn't have name, it's anonymous, so it can only be used once. So that's why if you have, if your function is not simple, then you define the function, because the major functionality for function is to code reuse. Okay. And of course, for functions, another advantage is modular design. Okay. Okay, so let's see how lambda expression. So for lambda expression, the syntax is you need to have this lambda keyword. Followed by that is parameter list. One, parameter two, etc. Then colon, then expression. Okay, so let's see over here. You have the keyword. We only have one parameter called fit. Here is the expression. Okay, so it's just some number times the variable. Okay, times the parameter. Okay, so pretty simple one. The second one, same thing. So here we have two lambda expression. Lambda, the parameter, and some number times the parameter. Okay, so that's this lambda expression definition. And then in this example, we also see this width, basically it is dictionary. So this is the key part. This is the value part. So the value part is lambda. Yeah, so you see, if you use lambda to define the value part for dictionary, it's quite also the code is also very concise. Yeah, and the previous, like the comprehension, it's also involved like a code concise. Okay. And let's see, how do we call it? Is it so? Okay. So this is you try to access the dictionary. Okay, you specify with the key. And then you want to get the value. Okay, because this is a lambda expression, so you pass in with the argument. Okay. And for meter to feet, similar you can do. Okay, so you specify key. And then you need to plug in, because this is a lambda expression. You pass in with an argument. Okay, so that's chapter 1's coding examples. Okay, so we complete of the coding demonstration also. Okay, so I think that's all for today. So I'm going to stop recording.